So let's do another example of a truth table with a conditional statement. So let's use truth tables to show the logical equivalence of the statement forms P or Q, if P or Q, then R, and if P, then R, and if Q, then R. So we want to show that these are logically equivalent, which means I need to show in the truth table that they have the same column. So let's start to make our truth table. How many variables do you have? You have P, you have Q, and you have R. So you have 3 variables, which means you're going to have 8 rows in your truth table. So true, 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 false. Then you're going to change Q, true, false, true, true, false, false. And then you're going to repeat these 4 columns, but you're going to change P to be false. So false, true, true, false, true, false, 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 true, and false, false, false. Okay. So let's see, what are we going to need? Well, I'm going to need P or Q. I'm going to also need if P then R, if Q then R. So let's go ahead and make all of those columns, if P then R, if Q then R. Okay, let's start with P or Q. You're going to look at the P column, look at the Q column, and put an or between them. So it'd be true, 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 and then the last 2 rows would be false because they're both false. Now let's look at the next one, if P then R. So you're going to look first at the P column, that's your hypothesis. Your R column will be the conclusion. So true and true means true. But in the next row, you get a true hypothesis and a false conclusion. So that would be false. And then the next row, your hypothesis would be true and your conclusion's true. So another true. And then the 4th row, your hypothesis is true, but your conclusion is false, so that would be false. Now, the remaining 4 rows, your hypothesis is false, which means it's automatically going to be true. Okay. Right, so we finished that one. Now let's look at if Q then R. So you're going to look at the Q column first, the middle one, then R, and go across. So they're both true, which means it's true in the first row. A true and a false is false. Now the next 2 rows here, your hypothesis is false, which means it's automatically going to be true. Okay. And then the next row, they're both true. The row after that, you have a true and a false, which means you get a false. And then these last 2 rows, your hypothesis is false, which makes it automatically true. All right, so we've got all the pieces we need. Now we can start to make our 2 statement forms. So let's start with if P or Q, then R. So you're going to start by looking at P or Q, that's your hypothesis. And then you're going to look back at R, which is your conclusion. So first row, they're both true. Second row, you have a true hypothesis, but a false conclusion. So that's going to make it false. Okay, the next row, they're both true, so that's true. A true conclusion and a true hypothesis and a false conclusion makes it false. Now they're both true, so you would get a true here. A true conclusion and a true hypothesis and a false conclusion would be false. And then these last two, your hypothesis is false, so it automatically makes it true. Okay. So that's the first of our two statement forms. Now our remaining statement form is going to be if P then R and if Q then R. So we're going to look at these two columns, the two conditional statement columns, and put an and between them. So and they both have to be true. So true, false, true, false, true, false, true, and true. So if you look here, these two columns are identical. These are the same, which means that my two statement forms are logically equivalent.